This is the Unit 6 review. I'm going to go over the problems that you requested. So the first thing that we need to know is, I guess, what we're trying to do here. So we're going to simplify and find the excluded values. So a few things to remember when you're simplifying is you can't simplify things that are held together by addition. So 3 plus 2, 5, 3 plus 5, 8. And so if we try to simplify, like do the division first, we can't because they're held together by addition. Addition and division have very different properties. Order of operations won't allow it. So moral of the story is we can't divide until we change it to multiplication, because then it'll work with order of operations and that. So kind of just showing the similarities here. So 3 times 2 is 6, 3 times 5 is 15, which they're both divisible by 3, so we can divide out 3 out of each and be left with 2/5. So because it's held together by multiplication, we can cancel those out. So number one, our terms are held together by subtraction and addition. So we cannot simplify until we turn it into multiplication, which the solution for that is factoring. When we factor, we turn it into a multiplication problem. Okay, so first things first, I notice that they're all divisible by 5, so I'll go ahead and pull out a 5, which leaves me with 2m squared minus 3m minus 5. Bottom is also divisible by 5, and I have 5m squared plus 4m minus 9. Okay, so these are the exact same thing. I just turned the one, so now 5's held together by multiplication. We can now divide that out and get the correct answer. But I'm going to factor this some more. So I'm going to do, if you remember from last year, you learned how to factor this. You're going to do your A times your C. So side note, factor this. A times your C, which is 2 times negative 5, which is negative 10. And your B terms negative 3. So I need to find something that multiplies to give me negative 10, but adds to give me negative 3. And so I'm going to think I have negative 1 times 10, negative 10 times 1, negative 2 times 5, negative 5 times 2, and that's about it as far as that list goes. This is the one that will add to give me 3, though. Negative 5 plus 2 gives me negative 3. So remember, you take those numbers and you break up your middle term, which is the B term, and then you'll factor by grouping. So 2m times, oops, there's not a 2. The only thing they have in common is m. Right, so I pull an m out of each, and I'm left with 2m minus 5. And these have nothing in common, so 1 is the placeholder there. So I have m plus 1 over 2m minus 5. All right, so the 5's are already gone. So this is my numerator. Okay, so I've already factored the denominator. Let me go grab my paper so you don't have to sit through that again. But if you do need help on factoring, just let me know. But I factored the denominator and I got 5m plus 9 times m minus 1. So nothing else cancels out. So it is in its simplest form right there. The best we could do is factor out those 5's and then divide them out. Okay, so now I got to look for my excluded values. So excluded values means that x cannot become a number that won't work, basically. And the denominator can never become 0 because you can't divide by 0. If you don't believe me, ask Siri to divide by 0. All right, so your denominator can never become 0. So we canceled out this 5 that was in the original denominator, but 5 will never become 0 on its own, so we don't have to worry about that. What we have to worry about is this guy and this guy. Because they're multiplying together, we're going to use the zero product property and take any denominator factor and make sure that it does not become 0. Because if it does, it'll multiply and make the whole thing 0. So I just use my two-step equation work right here and say, all right, m cannot be negative 9/5 or 1. Okay, and there's number 1. Let me know if you need me to do any other of those, but that is how you do it. 5, very similar. But it is only held together by multiplication, so I'm actually good to go. But I'm going to break it up a little bit more. 7 times 10 times p times p times p times n divided by 3 times 10 times p times n. I'm going to do the excluded values right now, so I'm going to break it up a little bit. So if we analyze the denominator, we have 3 times 10, which the only thing that can become is 30. So 30 can never become 0 on its own. But we are multiplying by 2 variables. So the only thing that p, like the only bad number to put into p that would make the denominator 0 is 0, right? Because p is multiplying, if you think about it, like 30p cannot be 0. Well, if we divide by 30, or 30 times what gives us 0? Well, it's 0, right? So p cannot be 0, but also n cannot be 0 for the same reason. Because if one of them's 0, they're held together by multiplication, will make the whole thing 0. So those are excluded values there. And now we think, what can divide out? Because it is held together by multiplication, we can now do division. So 10 divided by 10 goes to 1. And then 1 times 7, 1 times 3, it stays the same, right? P divided by p goes to 1, keeps the rest of the problem the same. N divided by n goes to 1. See ya. So the simplified version is 7 over 3, and then I still have p squared n in the numerator. So that's my simplified fraction. Okay. 9. All right, so let's see what we're working with. We have a square, and it has equal area to a rectangle. All right. So if we do base times height of a square, it'll be the same as base times height. Now these are obviously not drawn to scale, but it will be equal to the base times the height of that rectangle. So just kind of pulling out what we have visually. But it wants us to find the length of the rectangle. So let's change this to length times width, since they're going to use that kind of language. All right, so I have the length times the width, and the length times the width. Now these are going to be different numbers, obviously, because for their areas to be the same, they'll have different dimensions. But yeah, when we multiply those two together, it'll be the same because they're equal. Okay, so let's analyze this square. We have 6x minus 7 is the length, and so we need the width, but because it's a square, it's actually the exact same. So length times width, 6x minus 7 times 6x minus 7. Now I could have put it squared, but I'll cancel stuff out anyway, so I'm going to leave it like that. And then a rectangle is also length times width. I don't have my length, but I do have my width. And I'm leaving it in parentheses so that I know that is my width, and it's multiplying to the length to give me the area. Okay, so what is the length? I need to get length alone. It's multiplying, so I'll divide. That cancels out, leaving me with L. Okay, so L equals 6x minus 7 times 6x minus 7 divided by, now 18 and 21, if I think about the multiplication for those, I can pull out a 3. That leaves me with 6x minus 7. So I factor it to turn it into a multiplication problem. Notice the top's held together by multiplication, the bottom's held together by multiplication. So we can divide those out. Anything divided by itself is 1. And then when we do 1 times 6 minus 7, it stays the same. And so we have no issues there. Now nothing else can cancel, so I'm done with 9. All right, 11. So I have lots of fractions. I need to state the excluded values and simplify. So in order to find the excluded values, I'm going to look at each fraction, make sure that it never becomes 0. So v plus 6 can never become 0. So v can never be negative 6, or it will become 0, right? And now to the left, 24 and 80 are both divisible by 8. Anything bigger than that? Does 12 go into 80? Nope, I think 8's the biggest, right? Okay, so we're going to pull out an 8v squared. So I can't see what v's really doing. Factoring helps me see it a little bit better, so that's what I'm doing right now, right? And then I'm going to get 3v, and then plus 10. Yeah, all right. So double check that, make sure you feel good about that factoring. Okay, so we're focusing on the left-hand fraction, right? So let's just ignore everything else for a second. This denominator can never become 0. Now, 8 times v squared, the 8 won't make anything 0 when it's multiplying, right? If we multiply by 8, we'll just make something bigger. But the v squared is an issue. It can never become 0. Square root, v can't become 0. So there's one excluded value also. Now, because they're held together by multiplication, if 3v plus 10 became 0, it would multiply and make the rest of that 0. So we got to watch that too. So 3v cannot be negative 10. Divide by 3, divide by 3. V cannot be negative 10/3. Okay, so excluded values all around. 3 of them. Okay, so that's what I do first with these multiplication. Okay, so I'm going to erase that real quick so that we see what we're working with. Okay, when you multiply, if you remember, you multiply straight across. So v squared plus 5v minus 6 times 24v cubed plus 80v squared. All over, I'm going to write the original 24v cubed plus 80v squared times v plus 6. So, remember back in the day, back in elementary school, if you're multiplying fractions, you just multiply numerator to numerator, denominator to denominator, right? So quick example, if I had 2/5, okay, and I had to multiply it by 1/2, remember, you just do 2 over 10, right? 2 times 1 is 2, which is 1/5, which makes sense because 1/2 of 2/5 is 1/5. Okay, so just to show you, you just multiply straight across, just to remind you. Okay, all right, so here's our fraction held together by multiplication. And so if you remember, because something's held together by multiplication, that means we can divide it out. Anything divided by itself goes to 1. Those are the exact same things, right? So then we're left with v squared plus 5v minus 6 over v plus 6. Now, because they're held together by addition here, right, v squared, 5v, 6, they're all held together by addition and subtraction. There's nothing else we can do, but we're going to see if we can factor the numerator. Because our a is 1, there's no other option than to have v there and v there, so we can use this shortcut and think what multiplies to give us negative 6? But adds to give us a positive 5, which will be this one. Okay, so we have v minus 1 times v plus 6 over v plus 6, which means v plus 6 divided by v plus 6 will give us 1, and then 1 times v minus 1 is v minus 1. So that's 11. And then 15. Again, I'm going to look at these fractions and make sure the denominator never becomes 0. So I'm going to do a little bit of factoring on the left-hand side. Okay, and then some factoring on the right-hand side. All right, so if we look at the left, k can never become negative 7, or it'll create 0, multiply by 9, and make that 0. Same thing on the right, but what if that k becomes 0 that I just underlined? Then it would multiply by 4, become 0 also, and then distribute in and make the whole thing 0. So k cannot be 0. Okay? All right. So I'm going to look at the numerator now, factor that, pull out the GCF, and then I'm also going to do this one while I'm at it. Okay, so I'm going to just look at the left-hand fraction. So we have 9k plus 10 divided by 9k plus 7. I'm going to cross off my 9s. They're gonzo, okay? So on the left now, I have k plus 10 divided by k plus 7. Now instead of dividing by a fraction, we learned multiply by the reciprocal when we're young, and we're going to do that. So the reciprocal is when you take the fraction and flip it, basically. So the numerator becomes the denominator, denominator becomes the numerator. Okay. All right. So now we're back to multiplication, and if you remember, you just multiply straight across. So I have 4k times k plus 7 times k plus 10. And in the denominator, I have 5 times k plus 10 times k plus 7. Everything's held together by multiplication. The k plus 7's held together, multiplying to those two, so we can divide it out. K plus 10's held together by multiplication, and we're left with 4k over 5 as our simplified piece. But we have to pause for a second and notice that we did create a denominator. And so k can also not be negative 10, because in the process we created a denominator, and you can never have your denominator 0, so you have to look at all of them. So there's the simplified answer, and then our excluded values, not forgetting the new denominator that we created. All right, so there it is. Let me know if you have any other questions.